Hello, here we go. So let me change the title of this stream. Okay. This will be a GCP Professional Architects streaming episode 3. I'm still not sure what will be exactly the content, as we have a lot of material and there are many things we can do. Okay, so let me move some windows on other desktops. Okay, and here I will open my Cloud Skill Boost. Let's go. So here we go. Let's see. Sign in. Okay, we are in. And wait, we are here. We need to get here. About 6 hours remaining. Oh, let's go. So we need like just 20 points or more, like 30 points. Okay, we can do this. Okay, my learning path. Let's resume the course. So I was here. Let's see. I completed all of these. Okay, so this is another module of this course, which will cover some techniques on how to provision a cloud solution and how to manage and provision cloud solution. Okay. Oh, just a second. Mark has completed. Let's go. We already have 5 points more. Okay. Okay. Okay, so we are continuing the use case of symbol. We are having some examples of trade-offs we will need to consider when configuring the networking. Okay. Hmm. Man, this use case is so complex. I'm not even sure it makes sense to start from here because I lack a lot of things they are referencing. At the same time, this is kind of a really broad overview of not only the exam but also the cloud architect profession. So I will dedicate some time to this, but not only to this at this point. Maybe we'll do it kind of fast, not really deep. So I know where things are and I can get back to them. So, okay, they're just showing down how the complexity of this system could be. Let's see if my market is completed. Okay. Nice. Let's go. Okay, have it. Just a second. Is it marked as completed? Okay. So let's go. We have some questions, some practice. Let's see, passing 80% score. So Symbol Direct wants to create a pipeline to automate the building of new application releases. What sequence of steps should you use? Check in code, set up a source code repository, run unit tests, deploy, build a Docker container. Wow. I mean, run unit tests, deploy. It's strange to see deploy before the end. I will deploy at the end. Set up a source code repository, check in code, run unit test, build a Docker container, and deploy. This looks like having more logic than the others because set up a source code repository for me is the first thing. Check in code, I'm not sure what does mean. GCP check in code. Is this something? No, this doesn't look like a standard procedure, just a word to say that you are basically receiving the code in the repository. I'm not sure. Or like, checking the code. Yeah, then you run unit tests, which makes sense. After you see that the code makes sense, you run the tests, and then you build a Docker container. So you have this Unity, which you can deploy on some clusters. Let's go. You need to deploy a load balancer for a web-based application with multiple backends in different regions. So you need to deploy a load balancer for a web-based application with multiple backends and in different regions. Fuck, man. You want to direct traffic to the backend closest to the end user, but also to different backends based on the URL the user is accessing. Which of the following could be used to implement this? The request is matched by a URL map and then sent to an SSL proxy load balancer. The request is received by the global external HTTPS load balancer. The request is matched. The request is received by the SSL proxy load balancer. I mean, the proxy for me will be after the load balancer. The request is received by the global external HTTPS load balancer. For me, this one makes more sense than others. A global forwarding rule sends the request to a target proxy, okay, which checks the URL map and selects the backend service. The backend service sends the request to the compute engine instance group in multiple regions. The request is matched by a URL map and then sent to a global external HTTPS load balancer. The request is matched by URL map where, I mean, who is doing this match? The request has to arrive through HTTPS. And yeah, I think this one is the only one that makes sense, because otherwise, where does the request arrive? And then a global forwarding rule sends a request to target proxy, which selects a backend service and sends the request to compute engine instance group in multiple regions. Yeah, that one is not changing, it's the same. So yeah, this for me is the only one that makes sense. Symbol Direct wants a layered approach to security when setting up compute engine instances. What are some options you could use to make your compute engine instance more secure? So layered approach, I don't know what this means, of course. I imagine that are different layers of access of rules. At each layer you have different ways of filtering and routing the request. Use labels to allow traffic only from certain sources and ports. Use a compute engine service account. Okay, so you label the sources and the ports, and you allow operations only if they are performed by specific service account. Use network tags to allow traffic only from certain sources and ports. Network tags. Okay, computers. Yeah, so use labels to allow traffic only from certain sources and ports. Turn on security boot and VTPM. Secure boot. Nah, this one doesn't really look as making sense. Use network tags to allow traffic on. Okay, turn on. So for me, it's one of these two, and the only difference is if using labels or network tags. It looks like that labels are, for me, something useful for analysis, not for security. This is my guess, because I'm not sure 100%, but yeah, looks like that network tags make more sense when talking about compute engine instances. However, I'm not sure that you have some tags which allow you to limit the traffic only from certain sources and ports. I think so, because there are a lot of tags available when you create a compute engine. So yeah, let's go. Your existing application runs on Ubuntu Linux VMs in an on-premises hypervisor. Okay. So I have my on-premises hypervisor, I have Ubuntu Linux VMs on it, and the application is running on them. You want to deploy the application to Google Cloud with minimal refactoring. What should you do? Okay, so set up a Google Kubernetes Engine cluster and then create a deployment with Autoscaler. We write Terraform scripts to deploy the application as computer engine instances. Remember, one of our business requirements is to go to select always managed services when possible, and between these two, I would like to select JKE, as this is a managed service. Use a dedicated or partner interconnect to connect your on-premises network where your application is running to your VPC. Okay, so this is another point. We want to go and move everything to Google Cloud, but it says with minimal refactoring. Isolate the core features that the application provides. Use App Engine to deploy each feature independently as a microservice. Okay, so in reality, looking at this solution here, use a dedicated or partner interconnect to connect the on-premises network where your application is running to your VPC. Okay, so I will use just a global external HTTPS load balancer to connect to these existing machines, basically. Minimal refactoring. So I would say that this implies less refactoring than deploying it on JKE, as we will need to create the containers. It's not a lot of work. Let's compare. So is it more complex to just create one VPC, one load balancer, and one partner interconnect? Well, for me, creating just an application container and launching it on some JKE clusters looks less work than all of these networking nightmare. You have deployed your front-end web application in Kubernetes. Based on historical use, if it's okay here. Yeah, looks like okay. You have deployed your front-end web application in Kubernetes. Based on historical use, you need 3 pods to handle normal demand. Occasionally, your load will roughly double. A load balancer is already in place. How could you configure your environment to efficiently meet that demand? This one, no, because this will be a steady number of 6 replicas. Edit your post configuration number of 5 to 6. So I will use Autoscale, of course. Okay, 3 pods. So I will double the pods. But yeah, I don't remember the difference between, yeah, like deployment spots. I have to check. Stateful, yeah, all those terms. I need to repeat them. Symbol Direct needs to use a tool to deploy its infrastructure. You want something that allows for repeatable deployment process, use a declarative language, and allows parallel deployment. You also want to deploy infrastructure as code on Google Cloud and other cloud providers. What should you do? Yeah, automate the deployment with Terraform script. Yeah, looks like Terraform is the solution because Terraform can be used also in Amazon AWS. Yeah. Symbol Direct must meet compliance requirements. You need to ensure that employees with valid accounts cannot access their VPC network from location outside of its secure corporate network, including from home. You also want a high degree of visibility into network traffic for auditing and forensics purposes. What should you do? Ensure that all users installed Cloud VPN. Enable VPC flow logs for them. Enable VPC service control and use Google Cloud Observability. Enable identity-aware proxy to allow users to access services securely. Use Cloud Observability to view. Enable VPC service controls. Define a network perimeter to restrict access to authorized networks. And enable VPC flow logs. So I don't want them to access from outside. So I need to define a perimeter. You are working with a client who also built a secure messaging application. The application is open source and consists of two components. The first component is a web app written in Go, which is used to register an account and authorize the user's IP address. The second is an encrypted chat protocol that uses GCP to talk to the backend chat servers running Debian. If the client's IP address doesn't match the registered IP address, the application is designed to terminate their session. The number of clients using the service varies greatly based on time of day, and the client wants to be able to easily scale as needed. What should you do? Fuck. Okay. So deploy the web application using the App Engine standard environment. Deploy web application using the App Engine flexible environment. Deploy the web application using the App Engine standard. Okay. With global external HTTPS, with global. So use an unmanaged instance group for the backend chat service. Use an unmanaged instance group for the backend chat service. Use an external network load balancer to load balance traffic across the backend chat servers. Use a global SSL proxy load balancer to load balance traffic across the backend chat servers. Okay, so the difference here, first of all, I should know the difference between App Engine flexible and standard, the difference between managed and unmanaged instance group, and the difference between the various types of yeah, there's an external network load balancer. So the number of clients using the service varies greatly based on time of day, and the client wants to be able to easily scale as needed. So you're working with a client who has built a information application. The application is open source and consists of two components. The first component is the web app return go, which is used to register an account and authorize the user's IP address. The second component is an encrypted chat protocol that uses TCP to talk to the backend chat servers running Debian. I think that this one is not really important in this moment. The number of clients using the service varies greatly based on time of the day, and the client wants to be able to easily scale as needed. Let's see, GCP App Engine flexible, yes, standard. The sandbox using the runtime environment of supported languages below. Applications that need to deal with traffic scaling. This time we result of application with the following characteristics: sudden extreme spike of traffic, run for free at a very low cost. Application instances run with Docker containers on computer engine virtual machines. Applications that receive consistent traffic experience regular traffic fluctuation, meet the parameters for scaling up and down gradually. Include native code. So looks like that we need App Engine standard. So I will exclude the second. Then let's use managed instance. So I will exclude the first. Then we need to choose between a global SSL proxy load balancer and external network load balancer. Global or regional load balancing. Global load balancing means backend endpoints live in multiple regions. Regional load balancing means backend endpoints live in a single region. External or internal load balancing. What type of traffic you are serving, HTTP, SSL, TCP. How to decide which load balancer to use. External load balancer. External load balancing includes four options: HTTPS, TCP, SSL, network load balancing. Network load balancer. While the global HTTPS load balancer is for layer 7, the regional network load balancer is for layer 4. Proxy-based load balancers. Google Cloud also offers proxy-based load balancer. They use the singularity between infrastructure. Generally speaking, your decision to use them will depend on whether you require SSL offload or not. You can find out more. Okay, so I think I will go with this one. Or I need to study more about that. Symbol Direct user account management. User account management app allows users to delete their accounts whenever they like. Symbol Direct also has a very generous 60-day return policy for users. The customer service team wants to make sure that they can still refund or replace items for a customer even if the customer's account has been deleted. What can you do to ensure that the customer service team has access to relevant account information? Ensure that the user clearly understands that after they delete their account, all information will also be deleted. Restore previous copy of the user information database from a snapshot. Temporarily disable the account for 30 days. Disable the account. Temporarily disable the account for 30 days. Export account information to cloud storage and enable lifecycle management to delete. This looks like better. Restore a previous copy of the user information database from a snapshot. Ensure that the user clearly understands that after they delete their account, all information will also be deleted. Remind them to download a copy of their order story and account information before deleting their account. Have support agent copy. Symbol Direct wants to allow partners to make orders programmatically without having to speak on the phone with an agent. What should you consider when designing the API? The API backend should be tightly coupled. Clients should know a significant amount about the services they use. REST APIs using gRPC should be used for external APIs. The API backend should be loosely coupled. I have no idea about this. Clients will not be required to know too many details of the service they use. Yeah, this looks like having more common sense. Let's see. 70% instead of 80. So the question about wants to create a pipeline to automate the building of new application releases. This was correct. I mean, the other option doesn't make sense. Each step is dependent on the previous step. There are right order. Okay. This one is the one about you need to deploy a load balancer for a web-based application with multiple backends in different regions. The request is received by external GPS, a global forwarding rules, the tower proxy which checks URL map, then backend service compute instance group in multiple regions. This is the right order of operations. Symbol Direct wants a layered approach to security when setting up Compute Engine instances. What are some? Okay, so layered approach to security. I did it wrong. Incorrect. All Compute Engine instances have an associated service account. Creating an account specifically for an instance or type of instances with limited ability instead of the default account could be a good approach to the principle of less privilege. Have an associated, create an account. Use a Compute Engine service account. I'm not sure what does this mean. Like, all Compute Engine instances have an associated service account. Creating an account specifically for an instance or type of instance with limited abilities instead of the default account could be a good approach to the principle of less privilege. Okay, so use a Compute Engine service account is not the right way to do things. So we need to choose between these other two. I will go with network tags. Your existing application runs on Ubuntu Linux, blah, blah, blah. And I chose the Kubernetes because in my opinion, it was the way to minimalize refactoring. Changing from a virtual machine-based application deployment to a container-based deployment will probably require refactoring. Okay. So with refactoring, they were specifically referring to refactoring the code. So if they don't want to refactor the code, maybe they would accept as an answer also the Terraform scripts. Yeah, like using App Engine will need refactoring. Yeah, we'll see. Maybe it's better the Terraform script to deploy the application as Compute Engine instances. You have deployed your front-end web application in Kubernetes based on historical use. You need 3 pods, blah, blah, blah. Will roughly double, and the choice was about the deployments maximum number, correct? This will allow Kubernetes to scale the number of pods automatically based on conditions like CPU load or requests per second. Symbol Direct needs to use a tool to deploy its infrastructure. You want something, okay, Terraform. Symbol Direct must meet compliance requirements. Okay. Enabling VPC service control lets you define a network perimeter. Okay, so VPC flow logs lets you log network level communication. Okay. This is the other wrong answer. You are working with a client who has built a secure messaging application. The application is open source and consists of 2 components. Okay. I chose to deploy the web application with App Engine standard, and critical part is a global SSL proxy. The traffic is already encrypted, so there's no need to offload the SSL to the proxy. Okay, so we will have also problems with the IP address. Okay, so in this case, I think I will choose the other one. We'll see. Symbol Direct's user account management app allows user to delete their account whether, okay, temporarily disable account, cloud storage for 60 days. Symbol Direct wants to allow partners to make orders programmatically, REST APIs, loosely coupled. Okay. Let's retake this. Okay, must meet with compliance requirement. So this was about the VPC service content, define parameter and then VPC flow logs. Let's go. Symbol Direct's user account management app allows user to delete. Okay, so I will temporarily disable external account storage. Okay. Symbol Direct wants a layered approach. Okay, so use a compute engine service account is not the right way to do things. And between these two, I will go with network tags. Symbol Direct wants to create a pipeline to automate the building of new application releases. And it was set up, source code repository check-in, run unit test, build, and deploy. You have deployed your front-end web application in Kubernetes. Based on historical use, roughly double. Okay, so kubectl autoscale deployments maximum number instances to 6. You are working with a client who has built a secure message application, and in this case, I have to avoid the global SSL proxy. I have to avoid the engine flexible, app engine flexible, and I will go with this one with managed instance group backend chat servers and external network load balancer. Symbol Direct needs to use a tool to deploy its infrastructure, Terraform. You need to deploy a load balancer for a web-based application with multiple backends in different regions. Not wrong, this was wrong. And oh shit. Oh no, I did it right. Yeah. So there is a global external GPS load balancer, roles, blah blah, backend, sorry, provisions. Yeah. Your existing application runs on Ubuntu. Okay, so this will need refactoring. Maybe this one is already covered. This one will need refactoring. This one looks crazy, man. Costly. At the same time, looks the easiest. Not sure, but yeah, we can use Terraform. Symbol Direct wants to allow partners to make orders programmatically without having to speak on the phone with an agent. What should you consider when designing the API? Wait, if I use Terraform scripts to deploy the application as compute engine instances. Oh, but the application is already compiled, I think. So Terraform scripts will just need to include integration of the compute engine in the memory in this application and just run it with scripts. Okay. And here we go. We have this other. Oh, yeah, this was. I did it correctly. Loosely coupled and REST APIs. Submit. Oh man, 100%. Man, let's go. Next. Okay, so let me see. Welcome to Module 2, Managing Provisioning. Okay, review. Let me just do like this so I can see everything. Okay. Consider extending to on-premises environment, multi-cloud environment, and security protection. Incorrect. Cloud VPN, let's VPN. Oh, so must be compliance requirements. Oh, okay. So this one was B, right? So B correct. Okay. I mean, I will have to study VPC. Load, choosing load balancer. Yeah, for sure. I will need to study it. Architecting with Google Cloud Compute Engine. Elastic. Okay, so I already took note of these courses here. Okay. Oh, so in my sticky notes, I have architecting with Google Cloud Design. Okay, so I took note of this one and also this one. And here we have architecting with Google Cloud. Yeah, again, the same two courses. And oh, okay, so we have also some documentation about Terraform. Again, Terraform, API design. Okay. Architecting, yeah, reliable Google Cloud structure and getting started with Kubernetes. Yeah, I took note of it. Architecting, yeah. Okay. Okay, nice. Therefore, this one is also completed. We can go forward and take the knowledge check for this module. Let's see. Which network configuration will ensure low latency for US drone pilot? Deploy resources globally. Only deploy resources to region in the US. I mean, which storage class should you use for database going to be accessed at least once every 2 weeks? I would say that standard will be like every day, at least once every 2 weeks. I would say inline. So needing for storage less than or once every 30 days. Okay. So it's standard. I will need to study the storage options. Great. Okay, I will not proceed with this one at this moment. Nice. So I already took and completed these 3 modules in the course. I'm at 42% of the overall course, and I need to complete only these other 4 modules. Let's go. In this case, here, provides not provided session make profile public. Make profile public, yeah, who cares? I mean, I want people to be able to see my path. Yeah, I have my path already. I want to be an architect. And I went 4% of the whole path. Oh, nice. So let's have a look at my notes. So Google Cloud Fundamentals, Core Infrastructure, Essential Google Cloud Infrastructure Foundation, Core Services Foundation, okay. Elastic Google Cloud Infrastructure, Scaling and Automating, okay. Reliable Google Cloud Infrastructure Design and Process, Getting Started with Kubernetes, okay. I think that architecting, yeah, I mean, I think that I just need to proceed with all the courses here. I'm not sure if this cloud architect journey is really important for me. It looks like this could be more useful for those who really already know a lot and they have to select. But in my case, I think it will be better to do all the available content in this path. So I will take all the courses. I will not jump anything. And as I mentioned, I will not do only cloud skill boost. It looks kind of boring at certain points. For sure, it's useful as it gives an overall an overall view of all the content that is necessary to own, to be really secure about how it works. But I think that for more practice, I will use also other um, learning sources. But yeah, I'm also kind of impatient for sure now that I will start some cloud skill boost laboratories. Maybe this will be funnier and I will change my mind and I will stay only with cloud skill boost. We'll see. For now, yeah, I'm happy to just connect and learn new stuff, or just to repeat, refresh, have a better comprehension of something that maybe already encountered in my past. And it's always good to repeat and repractice.